think this might be the final video for statistical applications. This one is very important if you go to work for a company, Lilly, Cummins, whoever, and I've heard from their statisticians there that they wish that engineers could learn how to determine a sample size. If they are given, if the researchers want, hey, I want a 90% confidence interval, let's say that is 10 centimeters wide. Really the only thing you have control of, X bar is going to come from your sample. Sigma will be given to you, or you'll compute S from your sample. 90% already tells you then your confidence level, and the corresponding z-score is 1.645. So the only thing that can get you down to 10 centimeters if you have a wider confidence interval is your sample size n, because if you think about it in the formula here, this n right here, as we increase it, it makes this number smaller, which will make the amount that you go out in each direction smaller. So n, it's a very nice problem to be able to tell somebody you need to choose 100 samples so that your confidence interval is this tight. So, a lot of times if you're running an experiment or something, you'll realize you don't need to take, 100 samples. Maybe you only need, maybe you need half of that. Maybe you need 50 to get a tight enough interval to answer the question you're looking at. So you can see why then that this is important. It will save you time and money if you don't need to collect as many samples. So we call this guy again the margin of error. So if you think about it, it's almost easier to do an example. This is the guy, X bar's in the center, and you're going to be told this. So this is the guy that controls how far in each direction you're going to go. Well, this whole term is called your margin of error, but this is a given, this is a given, and this is the thing that you sometimes have the chance to determine. So I want to set this thing equal to some error bound, or how big I want my margin of error to be, and then solve for capital N. So you can get a formula for this. You would just take z of alpha over 2 times sigma divided by square root of n, and say I want that less than or equal to some margin of error. I'll just call it ME. Solve for capital N, and you'll get z alpha over 2 times sigma divided by ME is less than or equal to square root of n. This is positive, so that's legal to cross multiply. I'm going to square both sides, and there I have my formula for computing n. But I don't memorize this formula. I just always think and build the interval and decide on the spot, how do I choose n. This formula always comes out in it, but I don't like to memorize things if I don't have to. So you could choose n larger, anything larger than this, but again, you would choose the minimum n that does this, so you don't have to choose a bigger sample. Looks like more of my videos are going to screencast. No, I want to go back to here. Okay, so let's do maybe both examples since I only have two. So what sample size is required to ensure that a 99% confidence interval? So imagine you're building a 99% confidence interval. Has a total width no greater than 20 units. So I want this to be at most 20 units long when sampling from a population with population standard deviation 30 units. So I want to determine n, right? X bar is in the middle, but the thing that's going to determine how far I go out is my z of alpha over 2 times 30 divided by square root of n. And because I want the whole width of the confidence interval to be 20, I want this to go out in one direction by less than or equal to 10 units. And so for a 99%er, that should be 2.58, right? So you leave 99 in the center and 0.005. Let's go to Z table fast. 0.005, yeah, 2.58. So this is 2.58. So I want to solve 2.58 times 30 divided by square root of n less than or equal to 10. And then I solve this guy for n, and so I'll just do a little bit more. 2.58 times 30 divided by 10 is less than or equal to square root of n, and then go ahead and square both sides, and we find out that n has to be bigger than or equal to whatever this number is. So again, I don't have Maple up, but this should not be a very hard calculation. And let's do this last one. Suppose we want a maximum margin of error of 0.8. Okay, when finding a 95% confidence interval for GPA of high school applicants. So I want a 95% CI for GPAs, and I want the margin of error in one direction to be at most 0.8. So again, you want an interval, like, again, that maybe, let's just say it was, let's say the true mean mu is 3 point or something. At most, at most I would want to err from what the truth is by 0.8 in each direction. So I want an interval that's at least this tight. Okay, so let me see, 95% confidence interval where the standard deviation is 0.5. Find the required sample size. So 95% leaves 0.025 in the tail. That's 1.96. So 1.96 times 0.5 divided by square root of n. I want this margin of error to be at most 0.08, which means I need 1.96 times 0.5 divided by 0.08 less than or equal to n. And this is square root of n, and I square both sides. And so I get a number, so n has to be at least, and if I get a decimal, I should take the ceiling, take one up from that number to make sure that I have a big enough sample size to make this tight enough. So we'll just cover in this kid's shirt and actually give him a little bit of hair color, and then we can be done with this video. So, let me know if there's more of these you want to see, and then I'll save this kind of stuff for the final exam.